Okay, Bismillah ar-Rahman ar-Rahim. Now we'll start this section, or chapter 8, math exponential methods. We'll talk about section 8.1, mathematical exponential linear systems. What we are talking about in this section. Now, in the last chapter, we were working to solve this system, the homogeneous system, x prime equal ax, where a is an n by n matrix of constant. We know that we are getting this general solution, C1x1 plus C2x2 plus blah, 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 plus Cn xn. Okay, where these x1, x2 up to xn are n linear independent solutions. Okay, I can write x of t as C1, x1, and I can write it as the matrix, this matrix, times these constants. In other words, it's 5t times c. What is 5t? These are just the solutions, huh? First solution, second solution, and so on. We call 5t a fundamental matrix for the system. By the way, don't forget each column of 5t is what? It's a solution of the system. I can write the solution, the general solution, as 5t times the constant vectors, which are c1, c2 up to cn. Okay. Now, this is if you talk about x prime equal ax, just the system, x prime equal ax. This will be my solution. I can write my solution in this format. Now, if I have the problem with initial condition, x prime equal x, with initial condition, x0 equal x0. What will be my solution? It will be 5t times the c. Okay. What will be the c? Yeah. It will be phi inverse times x0. Phi inverse at 0 times x0. That will be my c. This will be the constant vector in case I have initial value problem. In case I have initial value problem. That will be a unique solution. We know that when you have initial value problem and things are okay, everything is okay, has continuous functions, everything is smooth, then we can get a unique solution. In this case, we don't have a unique solution. Actually, it depends on C. So I have infinitely many solutions. Okay, but if we have initial condition, initial value problem, or initial condition, that's it. We're getting this x of t, 5t, phi inverse at 0. It's very easy. Just, yeah, you have x of t. How to get it? X of t equal 5t. Let me show it to you. X of t equal 5t times c. I know that x at 0 equal x0. So that means x0 will be phi at 0 times c. What will be c? I need to find the inverse of this. Don't forget, for fundamental matrix, I have n linear independent solutions. So for sure, fundamental matrix is invertible. It has an inverse. So C is what? Phi inverse. I multiply phi inverse in this equation both sides. So I have phi inverse at 0 in one side times x0. That will be phi inverse at 0 times phi of 0. This is I, which is the C. So this is my constant. So I plug it here. That's it. I'm getting the solution for the initial value problem. By the way, the fundamental matrix is not unique. You can get different fundamental matrix, but the difference between two fundamental matrices is just the constant. Just a constant matrix. Just a constant matrix. So if you have another fundamental matrix from psi of t, then psi of t, this is phi of t times the constant matrix. Just to remind you about finding the inverse, if we have 2 by 2 matrices, because I need the inverse, huh? I need to find the inverse. Okay, so you have 2 by 2 matrices. What you will do, you find the determinant of A, 1 over the determinant of A. These two, you swap them. You swap them. This one will be here, and this one will be there. And these two, you will multiply by minus. That's how to find them. I think you know it. For 2 by 2. For 3 by 3, you need the cofactor on these things. I think we concentrate about 2 by 2 to find the inverse. Okay, now let me do an example to find the fundamental matrix. How will find the fundamental matrix? It means I need to solve the system. It means I need to find a solution. First solution, second solution, and so on. Okay, so this system, if I let x prime, x and y, that will be what? X prime, 4, 2, 3 minus 1x. So I'm working with this matrix A. We'll find the eigenvalues like in chapter 7. That will be 4 minus delta, 4 minus lambda, 3 minus 1 minus lambda. That will be what? Lambda square. Yeah, minus lambda minus 4 lambda minus 3 lambda minus 4 minus 6 minus 10. In other words, this is lambda minus 5 times lambda plus 2 equals 0. So I have 2 lambda here. Lambda equal minus 2 and 5. Okay. So for lambda 1 equal minus 2, what will be the system? I have 6 and 2. 3 minus plus 2, that is 1 times k1. You know, we need to find eigenvalues, eigenvectors. I think we know it. Yeah, by the way, this is real and this thing so easy to do. That will be what? 6k1 plus 2k2 equals 0, and 3k1 plus k2 equals 0. Very clear, these two equations are the same. So I have k2 equal minus 3k1. So I let k1 equal 1. K2 will be minus 3. So V1 will be 1 and minus 3. Okay. Now for lambda 2 equal 5, what I will have? I will have what? 4 minus 5, that is minus 1, 2, 3. Minus 1 minus 1, that is minus 6. Times k1, k2 equals 0, 0. We'll find eigenvectors. We need to find eigenvectors. So I have what? Minus k1 plus 2k2 equals 0. Or 3k1 minus 6k2 equals 0. Very clear, multiply by minus 3, get the second equation. So I have only one equation where k1 equal 2k2. So let k2 equal 1. You get k1 equal 2. So v2, 2, 1. So I have x1 is what? 1 minus 3 e to the power minus 2t. And x2 is what? 2, 1 e to the power 5t. So it will be 5t. Just you list x1 and x2. You list them. You have x1, then x2. You get what? E minus 2t minus 3 e minus 2t, 2 e5t, e5t. That will be this one exactly. And my solution, my general solution, will be x equal 5t times c. What is the vector c? This is c1, c2. Okay. Now I have initial condition. X at 0 is what? 1 minus 1. And let's solve this initial condition. I know that system, that will be the answer, the general solution for the system. With initial condition, what will be the answer? It will be this. I have that. I need to find this multiplied by x0. Okay. So phi at 0 will be what? Phi at 0 will be 1, 2, minus 3, 1. What's the determinant of phi at 0 to find the inverse? That will be 1 plus 6. That will be 7. So what will be phi at 0 inverse? The inverse of phi at 0, as I said, for 2 by 2, determinant, and swap these two, the diagonals, and the off diagonal just multiply by minus. So you have what? 1/7. This is 1, 1, no different. This is minus 2 and 3. That will be phi at 0 inverse. So what will be? Now I need to do what? I need phi at 0 inverse times x0, then the rest times phi at 0. So I need to find phi at 0 inverse through x times x0. That will be what? 1, don't forget 1/7. 1 minus 2, 3, 1. What is x0? 1 minus 1. So that will be 1/7 times what? 1 plus 1, that is 3. Okay. 3 minus 1, that is 2. Yeah. So this. So the solution of the initial value problem. What is the initial value problem? When x prime equal ax and x at 0, 1 and minus 1. The problem with the system, the system of the equation plus the initial condition is what? X of t, phi of t times phi inverse at 0, x0. I know phi of t. What is it? It's this, e minus 2t, 2e5t minus 3e minus 2t, e5t times, I know this, I just calculated. Yeah, don't forget there is 1/7. Times, this is 1/7, 3 and 2. So the answer will be 1/7 times what? 3e minus 2t plus 4e5t and minus 9e minus 2t plus 2e5t, which is exactly this one. 3, 4 minus 9, 2. That's it. That will be the solution. Actually, you can find the solution using the previous method where I plug it just in this one. You have equations of C's. I can find the C's, like what we did in chapter 7. Okay. Another example. Now we need to solve this system. And as before, yeah. So to solve the system, sometimes they need, it depends on the eigenvalues, real and distinct, easy. Non-real, you need the formula, repeat it, you need to deal with it. So you need to find the system in a different, in any way, in the way we did in chapter 7. So I have solutions, list them, that will be 5t. Then how to solve the initial value problem, just apply this formula. Yes, I have 5t now, this times this. Okay. Or as I said, you can do it the long way through the C's, huh? I mean, like what we did in chapter before, thinking, yeah, where we find the constant. Okay. Now this one means it will be what? 2 minus lambda minus 5, 4 minus 2 minus lambda. That will be what? Lambda square, 2 lambda minus 2 lambda gun, minus 4 plus 20. That will be lambda square plus 16. So lambda equal plus or minus 4i. Now I deal with the positive lambda. Yeah, with the positive, yeah, 4i, not minus 4i. I'll work with 4i because this is a formula. So we need to follow it. So we have 2 minus 4i minus 5, 4 minus 2 minus 4i times k1, k2. That will be 0, 0. So I have 2 minus 4i k1 plus 5k2 equals 0. 4k1 minus 2 minus 4i k2 equals 0. You need to be sure that these two systems are the same. These two equations are the same. multiply by, yeah, multiply by, I can divide the second equation just to be sure they are the same, huh? I want to, and this is like a checkpoint. Now divide this by 2, so you have 2k1 plus minus 1 minus 2ik2. Multiply this by 1 minus 2i. Multiply this by 1 minus 2i, you will get 2 minus 4i. So we multiply 1 minus 2i with minus 1 minus 2i, you should get 5. Or otherwise there is a problem. That will minus 2i plus 2i. Gun. Multiply, divide by 2. I get what? 2 minus 1 minus 2i. No, sorry. This is, you multiply it by 1 minus 2i times this. Minus 2 plus 2i gun. This will be 2 minus 4i. Sorry, this is minus 5. And this is minus. So this is minus 5. So the answer should be minus 5. So this is minus 1. 4i squared, which is minus 4. So it's minus 5. So it's correct. So just like a checkpoint. And it's good we did that. So we notice it's minus 5. It's not 5. Okay. So we'll use, for example, the second one. So where I have, k1 will be what? 2 plus 4i over 4, another one times k2. Half times, not half, half plus I times k2. So I let k2 be 2, k1 will be, to cancel the fractions, it will be 1 plus 2i. Yes. So my vector v1 will be what? 1 plus 2i and 2. Okay. So that can be written as 1, 2 plus 2, 0 i. So this is b1 and this is b2. So it will be my first solution. It will be 1, 2 cosine 40 minus 2, 0 sine 40, which is what? Cosine 40 minus 2 sine 40, which is this one. And the other one is 2 cosine 40, which is this one. So this is x1. Yeah. So this is my x1. Just we list it as a vector. And what will be x2? X2 will be, x2, just reverse this, 2, 0 cosine 40 plus 1, 2 sine 40, which is what? 2 cosine 40 plus sine 40. This is 0, 2 sine 40. Yeah, which is this block. So 5t will be what? x1, x2. And the solution, or the general solution of this system is x equal 5t times c. Okay. Which is I can rewrite it as, since I have space, cosine 40 minus 2 sine 40, 2 cosine 40. Here I have 2 cosine 40 times the vector c1, c2. Now you have the initial condition to find the constant. As I said, either you apply it right away and you solve the equations, C1 and C2, or you can do it using the formula. If you have the formula, you'll be your C. And then multiply it by 50, and that's it. So I need to find phi at 0. What will be phi at 0? Yeah, sine 0 is 0, cosine 0 is 1, 2, 2, 0. What will be phi at 0 inverse? It will be 1 over minus 4 times what? You reverse these two, you swap them, 0 and 1, and this is minus. So you're getting what? 1 over 4. Let me multiply the minus inside. 0, 2, 2, minus 1. What will be my x of t? It will be 5t. Yeah. Times. No, I need, sorry. Before that, I need now c, which is phi inverse at 0 times x0. And that will be 1 over 4. 0, 2, 2 minus 1 times what? 0, 1. That will be 2, 1 over 4. 2. And this is minus 1. Okay. What will be my solution? It will be 5t times c. And this is c. So I have 5t, which is this big list. Where is it? Yeah, 5t, where is it? Where is 5t? I listed somewhere. Yeah, this is cosine 40 minus 2 sine 40, 2 cosine 40 plus sine 40 times 2 cosine 40. This is 2 sine 40. Yeah, times this is 1 over 4 times this vector. Yeah, that will be 1 over 4. Yeah, here we need to be careful. This times that will be 2 cosine 2t, huh? Yeah. Yeah, the space is too much. Okay, so I have 2 times the first element, 2 cosine 40 minus 4 sine 40 minus cosine 40, yeah, minus 2 cosine 40. This times this minus sine 40. What we have there? We have 4 cosine 40 minus 2 sine 40. If you look at this one, this is cancelled. So you have minus 5. Don't forget the 1 over 4. Yeah. Minus 5 sine 40. And here I have this. That is, which is this one exactly. Yeah. A difficult but lengthy one. Now another problem where you have repeated eigenvalues. Just I'm showing you different back in chapter 7 where 5t we can get 5t from different cases. Okay, then we'll go to the exponential matrix where it will be easier. Okay, then I need to find the eigenvalues. 3 minus lambda minus 1, 1, 1 minus lambda. That will be what? Lambda square minus 4 lambda plus 3 plus 1, which is plus 4. So this is lambda minus 2 all square. So lambda 2, 2. Now for lambda equal 2, what will happen? I have 1 minus 1, 1 minus 1. We know how to do these things. So I'm getting K1 minus K2 equals 0, or K1 equal K2. So my V1 will be 1, 1. We have only one eigenvector. One eigenvector. How to find the solution? I need to choose U1 such that A minus lambda I square U1 equals 0, but A minus lambda I U1 not equal to 0. Yeah, what is A minus lambda I square? Let me find what is A minus lambda I. Yeah, I think we did that somewhere. That will be A1 minus 1 minus 1. What will be A minus lambda I square? Use Cayley Hamilton, this is 0, but let me find it so we don't have Cayley Hamilton theorem. That will be what? 0, 0, 0, 0. Okay. So I will choose U1 equal 1, 0, where I know times this, for sure it will be 0, since this is the 0 matrix. So anything times that will be 0, or this matrix times any vector will be 0. So for this one, for sure it will make it. And actually I need to find U2 using A minus lambda I times U1, and that will be 1 minus 1, 1 minus 1 times 1, 0, which is the first column, actually 1, 1. Okay, so what will be my solution? I know from here that x1 will be 1, 1, what was e to the power 2t, and x2 will be 1, 1 t plus 1, 0 times e to t, which is what? Which is t plus 1, okay, or 1 plus t times e to t. So this is my solution. So it will be 5t, fundamental matrix. It will be x1, x2, where I can write it, yeah, e to t, e to t, and this is 1 plus t, e to t, t, e to t, or in other words, I can make it this way, which is similar to this one. This is 5t. Now I need to do what? I need to solve the system. So I need to find phi at 0. Yeah, don't forget to find the system. I need to find the c well through this. And we know that the general solution will be what? 5t times c. How to find the c? Through the phi at 0. Phi at 0 will be what? For t0, e to the power 0 is 1. So I have 1, 1, 1, 0. How to find the inverse? Phi inverse at 0. That will be 1 over minus 1. This is, replace them. This is minus 1, minus 1. So the answer is what? 0, 1, 1, minus 1. Yeah. Okay. Now, what will be my c? C is phi inverse at 0 times x0. This is my x0. Oops. And that will be 0, 1, 1 minus 1 times 1, 0, which is what? This times this is 0. This times this is 1. Okay. So my solution of the initial value problem, which is x prime equal ax and x at 0 will be equal x0, which is 1 and 0. That will be x equal phi of t times c. What is my phi of t? E to t. That will be 1 plus t, 1 t times 0, 1. That will be e to t. This will be what? First row times second column. That's the first column. That will be 1 plus t. This is 0 plus t, which is this one. So this is my answer. Okay. Let me do a third example or the fourth example. Find the fundamental matrix. Now we're talking about it in clear steps. And it finds the fundamental matrix, general solution, then solve the initial value. Actually, what we did, but now is specified in parts. Okay. So I have A minus lambda I. That will be 1 minus lambda 3 minus 2, 6 minus lambda. That will be what? Yeah, lambda square minus 6 minus 7 lambda. Okay, plus 6 minus 6. Plus 6 plus 6 plus 6 plus 12. Yeah, it is plus 6 minus 2 times 3. Yeah, if you want to do it in steps, plus 6 plus 6. So that will be lambda square minus 7 lambda plus 12, which is lambda minus 4 lambda minus 1. 3. So lambda equal 3 and 4. Now for lambda equal 3, I need to find the eigenvalues, the eigenvectors, I mean. I have what? 1 minus 3, that minus 2, 3, minus 2, 3 times k1, k2 equals 0, 0. I think we did it many times. I have clearly one equation. So I have k1 equal 3 over 2 k2. So I let k2 equal 2. K1 will be 3. So v1, 3, 2. And also x1 will be 3, 2, e 3t. Now for lambda equal 4, 4. Yeah. I have what? 1 minus 4, which is minus 3, 3, minus 2, 2, k1, k2 equals 0, 0. Very clear, I have k1 equal k2. No need to waste time. So let k2 equal 1. That implies k1 equal 1. So I have b2, 1, 1, and x2 will be 1, 1, e4t. What will be my 5t? Which is the fundamental. This is a. This is the start of a. This is the end of a. So just list them. I have what? 3 e3t. 5t will be what? x1, x2, and then it will be, just list them. 3 e3t, 2 e3t, and what x2, e4t, e4t. That will be my 5t, which is this one. Part B, what will be the general solution of this? That will be 5t times c, which is, I can write it this. Times c1, c2. That will give me, yeah, if you want to write it as a solution or as rows, it will be 3C1 A3T plus C2 E4T, okay, and that will be 2C1 E3T plus C2 E4T. Okay, that will be part B. Part C, I need to solve this system. What will be my solution? I of T times C, which is phi inverse at 0 times x0, where this is my x0. Okay. So I need to find phi inverse, phi at 0 first. That will be what? That will be from here. This is phi. So just substitute at 0. That will be 3, 1, 2, 1. What is phi inverse at 0? I need to return it, which is 3 minus 2, which is 1. Very clear. So no need. That will be 1, 3 minus 1, 2. That's 1 minus 2, sorry. Okay. Then I need to find C, where C is phi inverse at 0 times x0. That will be 1 minus 1 minus 2, 3. Or can from here make it equal to, and if, yeah, to find the C's, solve the equation, or you can do it right away. Times minus 1, 1, you'll get what? Minus 1 minus 1 minus 2. 2 plus 3, 5. Now, my solution. Now, solution of this initial value problem. X of t will be phi of t times c. That will be, what is it? 3 E3t E4t 2 E3t E4t times minus 2 and 5. That give me what? Minus 6 E3t plus 5 E4t. And this one minus 4 E3t plus 5 E4t, which is exactly this one. 5 E4t minus 6, yeah. That's it. Yeah, I think we did a good example about this fundamental matrix, where we explain it. And the fundamental matrix is just, we list the solutions as a matrix. The solution as vector, we list them as a matrix. We call this fundamental matrix. And if you have the system, as I said, x prime equal ax, what will be the solution? It will be this fundamental matrix times the C, the C, which is the vectors, the list of the vectors. If you have initial condition, this C will be phi inverse at 0. The matrix phi at 0, the inverse of that, times the initial condition, which is x0. Then multiply it by phi of t to get x of t. And this, we did many examples to make this very clear. Where to find phi of t, you need to solve like in chapter 7, to find phi of t. So we did different cases where we have real, distinct, not real, repeated. Yeah, we did these examples. I think that will make it very, very clear. So next video, I will do the exponential matrix. Let me stop the recorder. So just we did this fundamental matrix of solution and how we find it and how to solve the system and the initial value problem using these what do you call it? The fundamental matrix. Okay, I will stop the recording. Thank you.